Bandwidth for changelog is provided by Fastly. Learn more at fastly.com. We move fast and fix things here at changelog because of Rollbar. Check them out at rollbar.com. And we're hosted on Linode cloud servers. Head to linode.com/changelog. This episode is brought to you by Rollbar. Move fast and fix things. Resolve errors in minutes and deploy with confidence. Head to rollbar.com/changelog. Request a demo. Get started today. It's loved by developers, trusted by enterprises, and most of all, we use it here at changelog. Move fast and fix things with Rollbar. Once again, rollbar.com/changelog.
Welcome to JS Party, a community celebration of JavaScript and the web. Tune in live on Thursdays at 1 p.m. Eastern, 10 a.m. Pacific at changelog.com/live. Join the community and Slack with us during the show at changelog.com/community. And follow us on Twitter. We are at JSPartyFM. All right, let's do this.
All right, the sound of those beats means it's your favorite and my favorite party time. It is JS Party time this week. Hi there, I'm KBall. I'll be your MC today, and I am joined by three amazing panelists. First, Divya Sasidaran. Divya, how you doing?
Hello. Pretty good.
We also have two elusive panelists, Mikeal Rogers.
Heyo.
And Feross DJ.
How's it going, KBall?
I am so excited to have this. I think the last time we managed to do an episode with both Mikeal and Feross on the same show, I was just sitting there with my mouth open, absorbing things the whole time. And Divya is going to add even more. Our topic for today, we're going to talk about refactoring large projects, which is something that I've been doing a lot of this last month or two. I joined a new company and got immediately thrust into, hey, here's this long-standing refactor that needs to get done. You have fresh eyes. Why don't you tackle it? But I want to really lean on the panelists here to get a lot of knowledge. So let's start with the first piece of the process of even decision-making, looking at our panelists, Mikeal, Feross, or Divya. Any of you chime in. How do you decide when is it time to do a big refactor? Should you do it? When should you do it? What code deserves to be refactored?
For me, it's when I have to. There's no other option. Sometimes you just realize, like, okay, it's going to be easier to rewrite this than it will be to use it in some other way that it wasn't actually designed for.
Yeah, I often find that refactoring is done, it's kind of the thing that people don't look forward to unless it's refactoring it to a specific concept or technology that you're really excited about. But oftentimes when you're refactoring large projects or legacy projects, it tends to be something that you'll push down to someone else. Hopefully you're you do it. Yeah, that's generally the reaction I often see. I've done it too, so I'm guilty.
It's funny because I feel like a lot of times devs have a reputation for over wanting to refactor. Oh, this code isn't perfect. I'm going to refactor it. This code isn't perfect. I'm going to refactor it.
I think young devs do that a lot. People have been burnt by that multiple times. Yeah.
When Mikeal creates stuff, it's perfect.
No. I've been pushing back recently. I think the younger you are, the less that you've heard of second system syndrome and things like that, and all the problems that come into place when you actually sit down to redo something.
It's interesting. It's you can go extreme in both directions. You can refactor too much, but you can also I've worked at some companies where they basically never want to refactor, and the code is just, the code looks like that. They're using stuff that has much, much better replacements and using methods that just aren't the best way to do stuff anymore. And they're really hesitant to refactor it because there's no tests, there's risk of breakage, it kind of works. And there's all these other things that we could do that seem more important to the product managers or the people who are making the decisions about what developers work on. So it can really go wrong in both ways, too much refactoring or not enough.
So do you have a decision-making process you use for deciding when you have to do it or when is the right time?
I think if you start to notice a lot of problems originating in one area of the code base, you find that a huge number of the last set of bugs that you've had to go and fix have some sort of source, some sort of root cause that's in common. It might be that that's a good place to consider or better design. I can also see if you feel like working in that part of the code base is really demotivational, like it feels bad to you, it discourages you, it makes you not want to do it, or like teammates on your team feel that way too, then it could just be like a big drag on everybody. And that slows down like the speed at which you can do stuff, and it just makes work less fun. So that would be another reason to do it. And that's more of an emotional reason, but it's also, that's like really important. There's probably other reasons. Yeah. What do others think?
I agree with the gut reaction thing, because that often is the reason I refactor certain things. Like I sort of know intuitively that it isn't exactly how I want it to be. And then that generally tends to motivate me to refactor it. And also it goes hand in hand with being excited about that refactor, because you think that it needs to be better and so you work on it. It's not always the case, because there are times when you think something smells, but then you don't want to touch it because it just is too much work, or you're gonna go down this rabbit hole of work and there's no light at the end of the tunnel. So there's always that fear as well.
I think there's also certain things for which there's no replacement for refactoring, right? Like if you're using a library and it has just like a way too big bundle size because it was never designed for that, you were just thinking about Node when you wrote it maybe, the only way to fix that is to refactor it. There's no like quick and easy way to just make the bundle size less. You end up using completely different modules and you end up doing things in a very different way. So you end up doing kind of a full refactor just to take that on. So there's certain cases in which you really have no other option other than just, maybe using a different library.
Well, alongside that, it's also if technology is deprecated. So like it's 2020, so Python 2 is completely deprecated. And so if your code is written in Python 2, you're going to have to move it over. And that almost necessitates refactoring, because otherwise your code won't work moving forward.
So that raises, there's sort of two different areas that cause refactoring. So one is code smells. Things are bad. I don't like this. It's causing bugs. And the other is there's some sort of functionality or requirement that this code is not meeting, and that its current structure means it is incapable of meeting. So I need to change it. The first one, I think, was what Feross and Divya, you were talking about first. Like, how bad is it? Is it causing a lot of bugs? I've seen, maybe even talked about it on the podcast with somebody, there's like these two axes that you can look at things, code on. It's how complicated or how complex is it, and how frequently is it being touched or modified. So you can have a super complicated, ugly function that just kind of works and you never have to touch it, and there's no reason to refactor that. Or on the flip side, you can have code that's changing a lot, but is actually really well factored and works well, and you don't need to refactor that either. But in that corner case of this is both really complicated and it's being modified or dealt with a lot, that's a place where a code smell indicates, hey, like this is probably worth refactoring.
Yeah, totally. It's about deciding, where the time is best spent, for sure. If the grossness is isolated somewhere and you never have to look at it, then it still could affect the rest of the system. Like if the performance is bad and that actually ends up causing problems for users or for developers. But if it's performing fine, and if you, from the outside world, that code is actually just doing its job well, it's just that when you actually crack it open and look at it, it's gross. It doesn't really matter so much if it's working. I mean, yeah, there's all kinds of things that people care about in coding, and style and aesthetic and stuff like this matters. But if, like you said, if you're not looking at the code very often, and there's no other glaring issue with it, like performance or security or it not being supported anymore because of the platform changing or something like that, then it seems like there's very little reason to expend effort there.
Yeah. The big refactor that I've been working on recently wrapped up, and then I'm looking at another one, were both the other category. They were related to new requirements. So in one example, it was, we have this service, it's great, except it doesn't enable streaming data. And so when the number of things you're working with get large, you're updating lots of things at the same time, it gets really slow. And unfortunately, the way it was set up, it was really hard to enable streaming. So we did this big refactor of the service to, in most cases, behave exactly the same way, but expose one more layer, which would let you stream it if you needed to. I think, Mikeal, your examples of, or even Divya's most recent of, like, okay, Python 2 is being deprecated. You must go to the new version. That's going to force some sort of refactor. So I think that's probably, I don't know. Well, what's your sense? Is that a more common case where it's new requirements forcing the refactor, or is it, code smells, complexity, and bugs?
I don't know if you can say it's one or the other definitively, because it often is, there's a mix of both. And even in scenarios where like there's one project being refactored, those two scenarios might exist for them to decide to refactor something. And that has happened before in code bases I've worked, where it's a matter of like one technology is being deprecated, like in the case of Python, or even in the case of React, when you go from React 15 to 16, which was like a major one that happened. But then alongside that, it's also like, things were not as modular, things were not as well built. Maybe using React hooks would make it better. And so there's like this idea of putting it, essentially it's a decision that the team or whoever's in charge of the code base has to make, whether or not it's worth the time and effort, because I think that factors in quite a lot. Because like, sure, refactoring is great and all, but like Feross was mentioning, does it actually add value? Because sometimes if a thing works, like refactoring is nice, but is it worth that time? Is it better for you to work on something else, like the user experience or like another project entirely?
Yeah, sometimes I worry that the developer community is really into fashion, and like refactoring for the sake of, well, this code doesn't look like what modern code is supposed to look like these days. And, the kids at school are going to make fun of me if I write code that looks like this. I can't go to school wearing that, like I have to fix it or else I'm going to get called out for being old school or something like that. So that's not a good reason. I think it should be more about, discovering that you picked the wrong abstraction and that, this abstraction is actually just making your life harder when trying to solve this problem. And so actually we're going to redesign the way that this class works, or we're going to redesign the way that this entire module works, because it's not exposing the right interfaces to actually help us get our job done. That's like more of a legitimate good use of time for refactoring.
I don't know. It's sort of arbitrary how you distinguish between a lot of those things. Like, how do you distinguish between it's a new hotness or it's a new requirement? Like, if you're building a new thing and you're using new stuff, like let's take like callbacks and promises, right? Like you're building a new feature, and so you're using the new promise-based stuff, and then you have to interact with some old library that is still callback-based, and there's some funkiness with it, so you need to refactor it for the new thing. That is a new requirement. Like there's new usage of it that needs this new pattern. And so it makes sense to just go and refactor it. I think that like, I don't know, you could paint that either way that you wanted to, honestly.
I wasn't subtweeting callbacks versus promises. I was not, I promise. That is actually a new requirement. And that is about, like the interface fundamentally being different. So I would consider that like legitimate for sure.
It does create kind of an interesting push-pull between. So we talked with Katie Seiler-Miller about Etsy's tech stack, and they had this whole principle of use boring tech, use stuff that's not on the bleeding edge, because they're delivering product. They're not worrying about the bleeding edge. But at some point that bites you in the butt, because like in the JavaScript ecosystem, things move so fast. There have been legitimate large improvements in the last year, 2 years, 3 years, and they're talking 5 or 6 years. Like, how long do you let something sit just because it's working as it currently is, but it's continuing to stagnate and be harder to find people to support and be harder to extend and do things like that?
Yeah, a lot of people say that same thing. Brian LaRue has the same thing, the use boring tech thing. I think that when you really nail down, though, what Brian does and what his team does is that that's not actually how they operate. Like what they're really talking about is like, it's fine to use the new thing or even the next thing, as long as the thing that you're working on is actually the next thing and not a thing that we're just going to ditch in a few years or is going to change so dramatically that the way that you did it doesn't really matter, right? Like, it's fine to take new syntax, but if taking that new syntax requires like a compiler chain that you wouldn't have used otherwise, it's probably actually not worth it. And just wait for that syntax to show up in the language that you're using and in the platforms that you're using natively. Like a lot of people really bet hard on CoffeeScript, and that turned out to not be maybe the best bet for a lot of those libraries. I think that you see a similar argument right now going in both directions about TypeScript. A lot of people think that it's like just everything's going to be written with this now in the future. And a lot of other people are saying like, I've been down this road before and it was called CoffeeScript and it didn't happen. And enough of the features landed in the language that we just kind of forgot about it. So I think, I don't think that anybody really believes that you should only use the thing that everybody was using 3 years ago in the JavaScript ecosystem, because we know that like anything that was super popular 3 years ago, we can see already what the next thing is beyond that. I think that what people actually object to is like using a thing that they believe won't be around in a few years, or, and there's a lot of arguments about, who is right about what's going to be around in the future.
One more quick question in this area of decision making about refactoring. Is it worth drawing a distinction between a refactor and a total rewrite? And when is one the right answer versus the other?
Can we define those things?
I guess that's part of my question. Like, is there a difference between, when we're saying refactoring, are we including in our heads everything up to and including rewriting this thing from scratch? Or is there a more contained definition there?
So I'll paint a definition. So one is like literally a diff. So you can think of it like it may be a major diff, but you can still see how all of the code got moved around. The other is like a new clean branch or a new clean repo that is just a complete reimplementation that is then presumably exposing the same or a very similar API that people can migrate to. So the end result is probably, an API that is either compliant with the prior API or only changed so much that people can easily migrate to it. But the approach to how you do it is a little different, in that you would either use the existing code or you would just start with a clean slate.
So then the idea for a rewrite, because it's a complete rewrite, would be that you can't gradually migrate to it. It's essentially you flip a switch, just a turn from one thing to another. Because if we define it that way, a refactor can be done in chunks where you work on certain pieces of the code base. Obviously, it might not be as clean as that. But with a rewrite, because you're rewriting the entire thing, then you can't just be like, use both versions, because they'd be in different states at any given time.
Yeah, I think there's also sometimes a problem of, like, there's a desire to rewrite because it is a blank slate, and you lose a lot of learnings. You lose a lot of stuff that maybe this thing that is kind of weird in the code was actually there for a historical reason that is not relevant, but maybe it was there because it works around an edge case that you haven't considered yet.
I actually disagree that you lose the learnings. I agree in terms of you lose the history of the learnings because you're moving from one entire code base to another essentially when you rewrite. So you lose that linear history that happens when you refactor on top of an existing thing. But sometimes when you do a rewrite, you can take whatever you learned from building it the first time and apply it to the new thing. And it might actually make for a better product just because you have a lot more experience and there's a lot of feedback that you had from the previous way of writing things that you can build into the application, the new application you're writing, without having to refactor it to reach that point.
All right. So would there be any reasons to do one versus the other that you can think of?
Off the top of my head, I feel like time is the one thing, because every time someone wants to rewrite something, especially if it's a large app, which is kind of what we're talking about with large projects, that takes so much time. It's almost, you might almost need a team just dedicated to that effort, because whenever you do a rewrite, the assumption is you're rewriting an application that people are using, which means that you might also have to be maintaining that project that people are using. So there's a lot of things that are happening at the same time. And so it's a matter of do you have the time and the people to work on it? Is I think a big contender when you think of refactoring versus rewriting.
Feross, Mikeal, thoughts on this closing piece for this segment?
I'm always just skeptical when people say oh, we're going to rewrite everything in a large app and it's going to be way better. I've just seen it go off the rails too many times and take far longer. I tend to like iterative approaches to refactor where, different parts are done in pieces and can potentially be more easily parallelized between different people and communicated well and tested independently. That's another thing too. I think that when you approach something iteratively, it encourages you to write tests and to deliver things in an iterative manner. And often when you need to do a refactor, one of the big pain points is that there weren't enough tests. And so that pushes you in the right direction. Whereas when you just go off and rewrite it all anew from scratch, the people who didn't write tests before tend to not write them again. And it's just the same problem all over again.
Yeah, I want to echo Mikeal. I feel like the tendency of programmers is probably like I said before, you can err too much in one direction or the other direction. They're both in terms of refactoring too much or not enough. And I think a rewrite is just like a more significant refactor, really, in terms of the definition of it. But it's probably worse to refactor too much, I feel like, in terms of just getting things done. Because I feel like we as programmers look at code and just say, "Oh, this is so hard to understand." And that's because like it is actually harder to read code than to write code. That's just how it is. So it's going to be like annoying to read someone else's code. And the instinct to just throw it all away and start over is like very strong. It's probably a lot of the time a mistake because that code, it might be gross for a reason, because those gross parts are bug fixes or learnings that ended up in there over time that will cause problems if you just throw it all out and start afresh. And the tests are also a big issue too. You won't write tests if you're just completely throwing everything out. So yeah, I would just say be careful when you feel like super strong feelings about throwing things out and starting over.
This episode is brought to you by DigitalOcean. DigitalOcean provides worry-free database hosting with their managed databases. If you need to get data in and out of Postgres, MySQL, or Redis, call on the world-class support teams at DigitalOcean and stop wasting time on setup, backup, and maintenance. Get simple, predictable pricing. Get detailed documentation. Get up and running in minutes so you can get on with your business. What are you waiting for? Head to do.co/changelog. Again, that's do.co/changelog.
Let's talk a little bit more about refactoring now, digging into approaches and tactics to make sure that your big refactoring project is going to be a success. Given that we talked a lot about tests in the last section, I think that will probably feature highly. But let's throw the question out first to Divya. When you're about to take on a big refactoring project, how do you approach that? What tactics do you use?
I feel like this is like just it seems obvious, but maybe not. One of the things I do is I try to basically isolate the piece that I'm trying to refactor, and then perhaps writing tests to cover those use cases to be like, this is kind of what it does at the moment. And it works as well for documentation for me as I'm refactoring it to figure out what exactly I'm doing. Because oftentimes when you refactor and you go very deep down a rabbit hole, you lose track of why you were doing it in the first place. And so sometimes for me, being able to write down what I'm doing in the form of a test allows me to isolate that piece of work, and also to make sure that when I refactor it, it does the thing that it was doing before. Maybe it's a little better, maybe it's the same, but slightly like easier to read. But it also keeps me on track, because oftentimes when I refactor, and this happens a lot, when you're refactoring one piece, you realize that there are other pieces that need refactoring, and then you just start going and touching every piece of the code base. And then there comes a point where everything is a jumble of like all kinds of diffs that, one, the Git history looks like crazy. You have all kinds of conflicts, and two, your refactor no longer works. So you refactor a bunch of things, but things don't work as expected. And so there's weird edge cases that happen. So for me, that's like one of the like very important things I do. It's almost like test-driven refactoring, just because it keeps me in check. It makes sure I do the thing I'm supposed to be doing without getting distracted really easily, which happens.
I really like the idea of doing it in phases. I think in the case where you don't have tests, which you shouldn't do that, but like say you have a code base that doesn't have tests and you need to refactor it anyway. If you do it in stages and you refactor one function or one file at a time, and each of those goes into a commit and then a pull request, and you go through a process for each piece, doing it piece by piece, then at least later on, if a bug is found and somebody says, hey, this like part of the thing, this part of the app stopped working, or this function now has a bug when I call it this way, then you can like write a test for the bug that they found at the time that it's reported, and then you can use git bisect to basically find the commit where it was introduced, and then you can be like, okay, then I must have made a mistake when I was editing this particular function or this particular file, because you can isolate the exact commit where it was introduced once you write that test later. But if you just did it all in one giant commit, then when you do git bisect, you're just going to be like, oh, So when I did that big refactor and changed every line of the project, then I must have introduced the bug there. And you don't really have an option to just revert. I mean, you could revert the entire refactor, but then, that's just like you wasted all the time, and you're going to have to now look through it to find where the bug is. Whereas if you just did a commit at a time for each little piece, then it's like not that hard to either just revert that one piece for now until you can figure out what the problem is, or to find the bug in that small piece, because it's not that many lines of code. It's much easier to find. So I don't know. That piece by piece is definitely the way to go.
I also find that whenever if you're working on a team that's working on a code base, that works really well, because when you're refactoring, there's often a specific GitHub issue associated with that refactor. And then when you do a pull request to the main code base, one of the things that I've done and I do regularly is that whenever you submit a PR for a refactor for a specific thing, there's a testing strategy that goes into it to be like, test that this thing works, test that this thing works. And having someone else look at the thing that you're working on or that you worked on gives you a second opinion on whether or not it's worth refactoring. Because there have been times where I refactored something, I created like a testing strategy in the PR, and it's been rejected because like what I thought needed to be refactored was not something that was worth adding to the code base, or that was not worth like integrating into the project itself. But overall, like in the event that it was, it's useful to have that history of like, one, like for us, you were mentioning having that Git history, but also having that history in GitHub, because I can look at a closed issue and I can see at what point a specific feature was refactored or worked on, and then just like trace back really easily. And for me, that's much simpler than using git bisect. I find git bisect very confusing personally. There have been times where I made like very small commits for things, which is great, but then when you use git bisect, there's just like all this history I have to go through, and then I lose where exactly I am, and then tracking makes it really hard. I'm sure tracking is supposed to be easy with it, but maybe it's just the task of having to go through all of your history and finding the one thing that introduced the bug is quite a big one.
It's one of my objections to Git squash, because you lose a lot of that history. And I think if you do small PRs, okay. If not, it can be a problem. I definitely have a tendency, if I'm doing a large project, to do it all in a feature branch and keep that branch up to date. But then if I squash it, bisect just goes away.
Yeah, also with large PRs, the one thing is like, it's a headache for a reviewer. No one wants to touch that. And then the other thing with feature branches, which can be good, is just like, again, it's isolated to the refactor or the task that you're working on. But the downside is that with feature branches, especially if it's an ongoing task and you're just constantly working on it, you have to really be on top of making sure that it's up to date, because if it's not, it goes stale really quickly. And then when you try to rebase to master so that everything or whatever, make sure that it's up to date with master, you get all kinds of conflicts, and that's like such a headache. And when that happens, I generally just like burn it to the ground and then start again, or just cherry pick the commits I want and then start all over again. So that's something to keep in mind if you do that kind of approach.
Yeah, if your team isn't already sold on the refactor, then certainly sending a small PR that's like, changing one file and saying, what do y'all think about this? This is the world we could be living in. Wouldn't this be so much better? Look at this one file I changed. But if you just change every single line in the entire project and say, guys, isn't this great? People are going to be like, what? No, I can't understand anything. And it's extremely intimidating to review it. And also, this is like a really important pro tip when you're refactoring. Don't refactor the tests and the code itself at the same time, because then you're not actually testing anything. Like, I've actually been dealing with this a little bit because I've been refactoring a lot of my code from ES5 to ES6, modern sort of class syntax and stuff, a lot of old packages. And it's tempting to just run a tool across the entire package that just turns the whole thing into, the new syntax for you, or, to just do everything at once if it's a relatively small package with, a couple hundred lines. But the problem is if you refactor the package and then you also refactor the tests and you introduce a bug in the tests at the same time, the tool changes something wrong in both the package and the tests, then the bugs can cancel each other out and it'll look like there's no issue. The tests will just pass. So you need to really keep the tests completely unchanged and fixed while you're refactoring the code in the project, so that the tests are actually confirming that, yes, it worked before and yes, it works after, right? So that's just something to keep in mind. It's kind of obvious when you think about it, but it's easy to forget.
100%. I think there's actually multiple things that you should do kind of orthogonally. So test is one. Work on the tests at one point, one commit, make sure everything's working. Structure, and then functionality, right? So if you're doing the refactor because you want to enable some new functionality, you should not add that new functionality in the same commit or same block of work as you're restructuring how things work. So I want to explore a little bit this kind of idea of doing things incrementally and how you approach it. So Feross, you mentioned, do one file and it's the new approach, or maybe it's using a new library or something like that. In a really large code base, it's pretty much impossible to refactor everything. So you're going to have to do some sort of incrementality. Like I've seen people use like this walled garden approach where they're like, okay, here's the good section that's onto the new approach and things move there over time. And once it's in there, it's got to stay in the new version, but not, or inversely, like here's the section of code that is old and shall not be touched and shall not be moved to the new version. Like what have y'all used for that?
Well, it's easier to do the walled garden approach if you are using a lot of packages to build up your application. And I know this is not like that common of an approach for building like an actual web app. It's more common in the open source world where, in libraries, in open source libraries where those are composed usually of a lot of packages. Because there you can just say, we're just going to refactor this one package for now, and then we'll do the next one after that and the next one after that. And so it's kind of like pre-decomposed for you in a way. It's like easier to do. I have less experience doing it on a very large web app where it's all in one repo and you have like maybe a framework that's tying everything together. So it's hard sometimes to be able to just like move to something else, like to switch, like say you're switching frameworks, like it's hard to, like I have no experience in doing that, like while the app is still functional, where you have like half React and half Vue or something like that. But yeah, I'm curious what other people have run into with that and how they've dealt with it.
So I have one recently that's kind of interesting. So I have a couple packages where in order for it to really be useful, it has to ship with a lot of dependencies that really kind of blow up the bundle size. And so you want to have the default in Node in particular, like have all this extra functionality, but also when people care, you really need to be able to pare that down and just ship with the things that they're going to use and need. So you have this big contrast between the two use cases. And so when I did this in a refactor, what I ended up doing was creating a new import endpoint that was like, /module/bear. And then that bear import doesn't give you any of the other functionality. You basically have to configure it with like different function calls. And then I just updated the main export, like the default, so that it didn't break compatibility, to just import that bear version and then add all the things that it had. And that seems to actually work really well and hit a lot of the same stuff. I had a similar situation in which we realized that in order to actually be quote unquote safe about some operations, we had to do like a lot of extra memory allocations. And so I ended up doing the thing that the Node.js core does, which is that you like the default API does all these extra mem copies. And then there's also paired functions right beside it that are called unsafe that do the unsafe thing. And in both of these libraries, it was really important that I had 100% test coverage in both, just so that I knew that I was actually hitting all of the code paths for all of these dimension points. But that model of refactoring seemed to work really well when I needed that new functionality but didn't want to break compatibility.
I like that bear approach that you mentioned.
Yeah, I like that. I think layering as well. In the project that I did recently, it was exposing a new API, but as I built out that new API, first I built it on top of the old API, and then I inverted it. So because the reason was to enable new functionality the old API didn't do. So I did the first version saying, okay, this implements the functionality, but it doesn't get the performance benefits we want. It's implemented on top of the old one. Rework the internals so that it can do more powerful things, and now rebuild the old API on top of the new one, if that makes sense. So you kind of, people who are utilizing the tools can choose to go to the new version, or in your case, they can choose to go to the bare version, but they can also still use the old API, even if I've totally ripped out the internals of it. I am curious, Divya, do you have any experience with the front-end multi-framework migration? Because that is something that I see happening in a few places. It's actually happening at my current workplace, but I haven't been super involved in it. And I think there are some trickinesses to that.
Yeah, I haven't worked on that kind of a thing per se, because oftentimes when I've worked on code bases, we've already picked a technology and we just move along with it. But it's often whenever we work with different frameworks, it's on different projects. So it's not on the same code base, thankfully. Although it has happened before. I wasn't part of this project, but Netlify used to be an Angular application, and then now we're a React app. So there was a huge refactor that happened from Angular to React. But I can't speak to that mainly because I did not write any of that code, and I wasn't part of that process at all. And this was like, I think 2016. So it's been a couple of years.
Yeah, I think I've definitely seen, situations where you're embedding components from one inside of the other. And so there's like a component by component migration process that sort of models the isolated process that we're talking about when it comes to packages. There, I think it was usually like touching things as they needed to be changed rather than doing, this functionality needs to change. We're changing the UI. We'll build the new version in, for example, React instead of Vue or React instead of Angular, or whatever you're coming from. But I didn't see as much of here, we're going to exactly replicate that old component using the new framework.
Yeah, I don't actually think that's possible because every framework has idiosyncrasies to them. And so if a component is written in Angular and you wanted to move it to React or Vue, you would have to take a different approach. It's not a one-to-one. So any framework saying it's just JavaScript is just a lie because it's not. If it's just JavaScript, it would be very easy to move from one to another, and it's not because it's very specific. So yeah, if you were to write it and move from one to another, it's always tricky. And I haven't heard examples of that process being smooth. It often is like very clunky. It requires a lot of work and a lot of planning. And yeah, because it's a rewrite, it's not a refactor at that point. Or unless a rewrite is a subset of refactoring. But yeah.
All right. What about other tactics, approaches, or gotchas that you've run into in big refactoring projects? Mikeal, I feel like this is an area you have a very opinionated approach to development with lots of small modules. So you probably have a different approach to this than folks in the massive monolith repo area. But what challenges have you run into, or what gotchas would you highlight for folks?
Well, actually, it's funny enough, like one of the things that the JS IPFS team is doing right now is moving to a monorepo, because it actually just got too complicated to have a lot of things in external modules that were really only consumed by JS IPFS and didn't really have a good reason to be outside of it. I mean, they do need to be separate modules, but they shouldn't be in separate repos because it just ends up being too hard to coordinate all the changes to them. So, I mean, there are like different approaches that you can take for different situations. And that is actually all part of another massive refactor that's happening in JS IPFS. Having small modules really helps you when you're refactoring. I would say that like, as much as we say that this helps with refactors, what usually ends up happening with small module authors is that they just write a new module. Like half the time it's just like, okay, well that old thing was like working, but I need a new thing and it's a big enough API change that why don't I just write a new library? And I think that that's one of the benefits to the small modules approach is that, because that could have, sometimes like instead of using my old library, I use somebody else's library because it matches the patterns that I'm going towards better. And because I broke things out into smaller components, it was easier to adopt a different library and swap something out, or, write a new library if I need to write it. So yeah, I mean, that always helps. That always makes it easier. I think that if you have, the more monolithic your software is, the harder that it is to update and increment in any way. And this is like a case in which it's particularly difficult. At the same time, if you have a large application built out of all these tiny things, the challenge is then coordinating all of those changes up. So if you have a refactor in one area that has implications throughout the entire depth graph, that update is really painful, like incredibly painful. Like I find it's easier to just set it aside and do the whole thing in parallel and, like basically ship a new version of the entire stack in order to do that, because it is quite difficult.
Interesting. I feel like there's a couple things to unpack there. So first off, your statement about essentially just rewrite a new module, is that in your mind what leads to the many old unmaintained module problem that we end up with in JavaScript?
I mean, is it a problem? Like, this is like a tree falls in the forest and nobody's there to hear it problem, right? Like, it is not a problem to have modules that nobody cares about or uses in the ecosystem.
Well,
and so if nobody new is adopting it, and then it doesn't actually have much of a maintenance burden and nobody really cares, and they can just move on to the new thing. I think that it's only a problem when like a lot of people depend on a thing that is old and are actively depending on it and building new things on it and it's not maintained.
yes.
That's a problem that you get in any ecosystem, like, because that's like a sustainability and governance issue. That's not even a problem with the size of something, right?
Well, yeah, but if your general tendency is, oh, I need something different, so I'm going to do a new version rather than I'm going to maintain and update this old version, I feel like that's kind of what led to the event stream situation, right? Like the original author had moved on 3 times or something like that, right? He's like, this doesn't work for me anymore. I'm going to do a new version. Oh, that doesn't work for me anymore. I'm going to, like, he was done.
Yeah, but like that is a better approach than breaking compatibility in that module. Because like a lot of those changes that he did in those new modules were different enough approaches that they would have been like backwards and compatible API changes. So it's actually like less useful to people that depend on a library to take a big breaking API change than it is to just build a new library, because nobody maintains those old major versions after they push a new major. So they're effectively saying, like, not only are we not maintaining the old one, you don't even get to update it anymore. And like, we're not really taking patches to update the old thing anymore. At least like when you go and build a new thing and you say like the break-in API compatibility is over here in this new thing, other people can go update the old thing that want to stay on the old thing.
Interesting. So it increases fragmentation, but that could be a good thing.
Oh, definitely. I mean, like we've had a lot of like painful upgrades in the JS ecosystem of moving to all these new patterns. But the one thing that has actually made it like not as awful is the fact that everything is so fragmented, and that like moving to new versions of a lot of these pieces and the new libraries is actually not as difficult as it would be if we had a lot of really, really big frameworks. Like, I mean, Python is, you know, it's been over a decade of them taking like relatively modest breaking changes, to be fair. And it's still a problem, right? Like we've gone through like, what is it now? We're on like the 3rd set of pattern breakages across the Node ecosystem, and like things are mostly working.
The Python case is astounding to me still. I don't understand the reasons behind it, but it is an astounding example of how badly things could go.
Yeah. I know Mikeal has a lot of thoughts on that, actually.
Well, I was using Python when that breaking change was taken. And that was one of the many things that led me to move to Node and adopt Node when Node came out. Because it wasn't just that they were breaking compatibility, they were breaking compatibility to resolve none of the problems that people had with Python. And in many ways made a lot of them worse. And so, yeah, like they didn't deal with like concurrency, they didn't deal with like the performance of the VM, they actually made the VM slower. Like all of the feedback that people who were using Python had about the language and the platform at the time were just not addressed by it. That was my main problem with it, which is that there didn't seem to be alignment between the core team and the ecosystem. And I think that that's one of the things that made the upgrade so painful, right? Like not only is this a breaking change where we have to update a lot of our code, but it's slower. Like why would we take it? And it doesn't address like the actual problems that we have that we're over here trying to solve. So yeah, I don't know. I don't think that we should index too much on that. I think that other languages have done breaking changes that have been much more successful. And I think in JavaScript, we don't really break. We just take entirely new parallel patterns that make the language incredibly large. And then we say like, everybody should use this now. It's worked surprisingly well. Like I'm honestly impressed with how much of the ecosystem has migrated to these new patterns. Like we effectively have a new language, and the old language is still there, but most people don't use it or learn it.
Yeah, it is a fascinating example of how the legacy of the web and the fact that JavaScript came out of the web has influenced it, right? Because the number one rule is you don't break the web, because there's lots of old stuff that has to keep working. So you end up with a situation where, anything that is a breaking API change becomes essentially maintained in parallel.
This episode is brought to you by Algolia, search technology to power your business. Trusted by Twitch, Stripe, Adobe, and many more. Even us. Yes, we use them to power our search, and we love the way they obsess over that developer experience. They let us fine-tune the index for the best results and report back what people are searching for, even surfacing search terms that get 0 results, which we love. Check the show notes for a link to get started for free, or head to algolia.com to learn more.
All right, let's talk pro tips, how to make your life, your career, your coding, what have you better. And we're going to start with Mikeal, because over the break he said he had a couple different things, and that's going to give Feross more time to think about it.
Cool. Yeah. So one is that so there have been like a half dozen popular package managers for Vim, and all of them are like kind of annoying to work with, and a lot of them really leverage Python, which is fine. Python's a fine language, but it actually doesn't have great startup performance, and so I found the performance really lacking in those systems. It turns out that Vim actually has a native package manager called Vimpack that I didn't even know about, and the way that it works is that you just put a bunch of stuff in this directory and then it just works. Like if you put it in the start directory, it starts up. And it's a little bit annoying to configure, but it's really like nicely repeatable. And so this fits really well with like the way that I build out my dev environment, which is like through this development container. So I now have a repository, Mikeal /dev-vimpacks. And this is just the Vimpacks. I actually only use one right now, which is like called Nerd Commenter. But that is now what I like it's part of my container build process where I pull that in and put it into each container so that I have all of those Vim modules there. So there's no like, external shell calls or anything, and no messing around with the Vim RC file. I just literally just put things in this directory, which is great. And then I think, secondly, I may have mentioned this a few times, but I've started to rethink the way that I approach programming as a practice. And part of that has been kind of debugging my own mind and thinking about the different states of mind that I'm in while I write code. And I started to document these a bit because as I talk to other people about dev setups and choices and things like that, it's good to get on the same page in terms of language. So at Mikeal /way-of-code, way-of-code, I've started to document that. And essentially, it's just like there are 3 kind of states of mind that you cycle through while you program. And each state of mind actually lends itself to very different tools and workflow. So that's an interesting thing to check out. And some people have been asking questions as well that I've been answering in the issues and whatnot. So that's about it.
Cool.
Awesome. Divya, are you ready? You look ready.
Yeah, I can go. So one of the things that I've been doing a lot this year in line with making resolutions, I didn't really make any resolutions, but one of the things I've been forcing myself to do better is I tend to push tasks that I don't want to do to the next day for eternity until I actually really have to do them. That includes planning for travel. If I have to go to a conference, I generally plan for travel not as early as I should, because I just really hate the process of doing that. And it adds to a lot of anxiety because I just generally keep thinking about the thing I should be doing, but I don't want to do, even though I have the time. Like I might have a pocket of time that I can work on it, and I don't, because I'd rather do something else. And so one of the things I've been pushing myself to do more is just to do the thing. So like just send the email. It's not that hard. And what helps with that is to write down, like in the morning, I'll just write down all the things I want to do, including all the micro tasks. And it really helps to write it down because then I can see what I need to do for the day, including big tasks. So if I need to write a blog post or create a specific tool, then I can work on those because that takes up a lot of mind space. But then when there are breaks in tasks that I'm working on, I can just look at the micro tasks that I need to do and do those, which actually adds to me getting things done more so than if I just don't write them down and try not to think that they exist. And that's really helped me just to like manage anxiety with not doing the things I should be doing, and also making sure that I'm tracking progress. Because it's nice to be like, oh, I only did 2 large tasks, but I did like 10 micro tasks. That's actually really satisfying. And then alongside that is also an eternal goal of mine has been just to write a lot more, because I don't write often. I tend to get into like rhythms of writing a lot and then not writing, which might happen again. But for this month, I've been blogging every day. And the way I've done that is through microblogging. So essentially, instead of expecting myself to write a really long blog post, I'll write a tiny one and like publish that. I've been publishing to Dev2 and specifically given myself like a area of focus. So it's January, so I created a blog series called Jamuary where I talk about Jamstack because puns are fun. And it's been great just because it's like, again, a task that I do every day. So in the mornings generally is when I write. And so I can sit down and write for, 30 minutes to an hour. And that gives me like, one, I'm accomplished because I did a thing and I published it in the world. And then that accomplishment, I can just ride that wave of getting things done for the rest of the day.
Awesome. I'll go next and then we'll close out with Feross. So my pro tip is to identify the things that you want to be learning and growing on, and then do everything you can to move the process of doing the learning and growing there out of volitional, something that you're deciding to do over and over again. So set up commitments and habits that are going to force you into a pattern of growth for those things. The best example I have for this was when I first started working on speaking and public speaking. I signed up for Toastmasters. I would go every week, regardless of whether or not I had something ready. I would go. It would force me to speak. It would force me to do things. Sometimes I was signing up for things that were volitional, but regardless, the default was to go, to put myself in an environment where I'm practicing, where I'm learning, and where the environment was going to encourage me to keep making progress on this thing that I had decided that I wanted to, because willpower is hard. And anything that you set up to require willpower will probably not happen, and it'll quickly fall off. And so commitments to other people and habits where you just go and it's not a decision, it's just something that happens, make a huge difference for your ability to actually continue to learn and grow. And if there's anything we know about our industry or the way the world is going, we have to continually learn and grow if we want to succeed. You have to keep moving in order to even stand still, much less get better. So identify what it is that you are working on right now. What is your learning path? What is your growth path? Make the decision once. Sign up for something that happens every week or every month or every day. What is it? So that it's no longer a decision you're making over and over again to learn. It's just part of your routine. And let's close with Feross. Feross, pro tips for us.
KBall, you should have gone last. That would have been the perfect one to end on. My pro tip is that one thing, along the lines of what you were saying, KBall, is actually to get in the habit of learning one new thing a day. Mm-hmm. So it's a thing you can incorporate into your workflow, so that it's not a thing that you have to go and spend a whole day learning a new thing, but it's like while you're doing a task, if you can find one part of it that can be slightly improved or slightly optimized, and if you just keep doing that over a course of a long time, you end up, that one small habit ends up, leading you to a place where, at the end of the year, you've learned a whole bunch of little things and you're much better. So along those lines, I have a concrete suggestion of something that's really powerful. I'm sure a lot of the listeners know about, bash aliases, or whatever shell you use. You can set up aliases so that you can type little shortcut words that will end up running a much longer command. If you don't know about that, check that out. It's really powerful. It's a really powerful way to sort of save a lot of typing for commands that you type really frequently. So stuff that I type really frequently are things like npm start or npm test. And so for those, I have little aliases where I can just type the letter T to run npm test, or you can type the letter U to run npm update, and little things like this that I do frequently throughout the day are just much faster now and a lot quicker to type. And also a really cool alias that helps me publish a lot of packages is I have little aliases for publishing new versions, because there's a whole set of steps that you need to run when you do that. Things like making sure that the current working directory is clean. You don't have changes that are staged, checking what files are going to actually be included in the package, running npm install and npm test and making sure the tests pass, actually incrementing the version and making a commit for that, setting a git tag, and then running any build scripts that may be present, or updating the authors that are in, if you have like an authors file. There's a whole bunch of things you can do. And then finally, actually pushing that up to npm. And I have all of that behind a single command, which is really cool. So I can literally just say patch or minor or major, And then like a whole series of things just gets kicked off, and it feels really powerful to be able to do that. So that's a huge pro tip for me. And if you ever wonder how some NPM authors can publish, like 20 or 50 times in a day, this is how they're doing it. They're not superhuman, like doing like things constantly. It's like they have like a giant script that's basically running, that's like doing all of the little things for them that makes things appear to be really fast. So that's my pro tip.
I don't even run this manually. I just have GitHub Actions do it.
Always one-upping me, Mikeal. You always got to.
Yeah, I read an article recently about how the combination of a cumulative advantage and winner-take-all effects means that oftentimes even 1% improvements, if you're 1% better than the competition in something, you can get disproportionate benefits, whether it's double the effect or 100% of the victory or what have you. So these little micro improvements over time, they add up and make a massive difference in your productivity and success. All right, with that, I think that wraps up our JS party for the day. Thank you everyone for coming. Thank you, Divya. Thank you, Feross. Thank you, Mikeal. This has been a lot of fun, and we'll catch you next week. This is KBall signing out.
Thank you for tuning in to JS Party. We record live on Thursdays. Come hang out with us. It's a lot of fun. If you have an awesome show idea or guest you'd like to have us invite on, let us know at changelog.com/request or hit us up on Twitter. We're JS Party FM. Our beats are produced by the one and only Breakmaster Cylinder, and we're brought to you by awesome sponsors. Support them, they support us. We've got Fastly on bandwidth, Linode on hosting, and Rollbar on bugs. Thanks again for listening. We'll talk to you next week.